So first, I want to go through introduce us. So we are Grand Staircase Institute, and this is a building nonprofit institute. So I'm the scientific director. So what we want to build to show people is we want to show people the pattern of nature. We named it the Grand Staircase because Grand Staircase it's a really majestic landscape here in southern Utah. Me and Rhiannon relocated. By the way, Erica is in California, but we are in the southern area of United States. We want to let people to understand how the connection between nature and art, and we want to combine all the possibilities together to show that no matter what age, what nationality you are, you can do art and you can do like science. So you're really welcome to send us emails in future about the interesting topic that you are in, or like just send us any advice, any topic you want to listen, you want to dig more, and then just we are open to all the choices and possibilities. Yes, and we're gonna have webinar series plus an art course basically every month, and then it's basically 1 hour's art course. First we're gonna have like 15 to 20 minutes thing talk about a specific topic to let people understand this topic more, and then we're gonna have those 30 to 40 minutes like our section. I want to introduce our speakers tonight. Miss Huang, or Erica, she is a mom of 4 and she's an artist and educator for 10 years. So you can see all those beautiful illustrations and art pieces she's been down there. And tonight she's gonna lead you to do the crystal journey, and then hope you really enjoy that. Please send us anything like in the chat to let us know that you can't really hear, or if there's a question. So one of the things my previous PhD advisor keeps saying that is like there's no stupid questions in this world. So no matter which section, as long as you have a question, just let us know. And I want to introduce Rhiannon to you too. So Rhiannon, she's a geologist. She previously she studied in the Southern Utah University. Then she transferred into the University of Alabama for like study groundwater. Then at New York, she studied crystal, which is our topic today. And then she's back in Utah. Actually, we are working on some of the public land lichen research questions now. And hopefully next year we can present the really fun result to you guys too. By now, I'm going to give everything back to Rhiannon and Erica.
All right, thank you. One thing I do want to add is that we love to see the art that you guys create. So I'm going to also be creating art along with you guys. So send us whatever you have, show us at the end, and hopefully that will help us grow as well. Let's start talking crystals. Yeah. So specifically, I'm going to talk about crystal colors and where all these colors come from. But first of all, it helps to understand what even is a crystal. There's quite a variety out there, but the definition for a crystal is actually pretty simple. It's just a repeating atomic pattern. So I gave one example here. This is a mineral called hematite, which is very common. If you know any red rock out here in Utah, we've got like Arches National Park or Zion National Park has the red rock, and a lot of times it's covered in this mineral called hematite, which is essentially rust, same thing that rusts your car or any metal. But the gray little things here, little circles, is oxygen, and then the red represents iron. So the iron and the oxygen are bonded together, and then they're also connected, and just the same pattern on the left here is just repeated down a chain on the right. All crystals, they might have different elements, might have different shapes, but the one thing they have in common is that it's a repeating pattern of atoms. So you can have the same crystal with many different colors. This is quartz, which you've probably seen in different forms, like amethyst is purple quartz, rose quartz is a pink, smoky quartz, and really you can have any color of quartz. And then vice versa. You can have the same color, but many different crystals. And here's some examples here. So let's go into what might be causing this and where we can get these colors. There's really 3 different reasons for colors in crystals, and we're going to go through each of them. One is the chemistry. So like I said, with rust, for instance, we have oxygen and iron, but you can replace maybe a small section of the crystal framework with a impurity or even an entire element and create a different color. Another thing you can do, part B here, is crystal structure. If you change the shape in any way, that can also affect how electrons, which, spoiler, they play a big role in how color forms. So if you change how electrons move in the structure between the atoms, then you can get a different color. And then finally, C, inclusions or additives. So that's kind of the white space in the crystal diagram there. If there's anything that gets caught in between these atomic bonds, it's bringing its own color, and it can create a color within the crystal. So we'll go through each one. So the first one, the chemistry, sometimes there's a lot, and so you don't think of it as an impurity, but oftentimes it just takes a little bit of an extra little atom, and it will create a really bright color. That's something that happens often. It's usually the smallest little, not even slightly bigger than an atom. Two atoms together can create a much brighter color than a whole crystal. So if you have a little impurity within a bigger crystal, for instance, this quartz here, which is just clear, but you add a little bit of iron inside there, and all of a sudden you get this smoky purple color, wherever that is. So as it happens, there's only a few elements on the periodic table of elements, which, if you're not familiar, these are all the elements that make up not just crystals, but everything in the universe, essentially. But the first row here that I have this blue dotted line around, there's only 8 elements on the periodic table that actually create colors in crystals, from titanium to copper. And it has to do with their placement here. Again, it has to do with how the electrons are moving around. They've got a little extra space for the electrons to energize and jump around. Here they are in a list. They have what are known as d orbitals. So orbitals are just the way that electrons are rearranged inside. And electrons have a big force charge, so they don't get along with other electrons. They have to come in pairs and weave around each other very well. So on the right here is an example of like a diagram explaining the slots that electrons have to fit in. So these elements often have a little extra slot that an electron from another element can pull it into their orbital, in this case a d orbital, and it can jump around. It can, if it's a higher energy or lower energy, it's going to change what color is the wave in the electron is vibrating. A good example of this is the crystal tanzanite. It expresses what's called pleochlorism. So tanzanite is often more of a brown color in nature, but if you heat it up, and that causes the electrons to move around a little bit more in that d orbital, it can change quite dramatically into a really bright blue color. And of course, a lot of different colors in between. And so that's creating one of those 8 elements. I don't actually know which one in tanzanite. And that's the thing. The elements can create different colors in different crystal structures. It's not a one-to-one. It's not like iron is always red. Iron, like you saw in the quartz earlier, was purple. They can create a bunch of different colors just based on the overall geometry of the crystal. Here is another example, tourmaline. It's a very colorful crystal. It can actually form very different colors, but it often has a different color on the inside than on the outside. And what's causing that is that basically the liquid that the crystal is growing out of, it has, it's like a soup. It has different elements inside, but when you use up one of those elements as the inside is growing, then it gets replaced by a different one, and then the outer layer is forming a different color because there's a different element. So that's how we get that watermelon tourmaline. So usually the pink in the middle, I guess tourmaline prefers to have the element manganese, and it creates that pink color. But when you run out of manganese, then it says, well, iron's good enough, and the crystal keeps growing, but instead of turning pink, it turns green. And so it can happen that the crystal is growing from the inside outward, or like in this last example, it seems to be growing from one end to the other and changing in a gradient. Okay, so the second cause of crystal colors, the crystal structure, really affects how those electrons are able to absorb energy. So in this case, oftentimes, if you have a nice repeating pattern in the crystal, that can encourage iridescence. So these pictures I have are examples: opals, mother of pearl on seashells, or labradorite, which is the upper photo there. That kind of color shifting is created not by a single element, but by very specific banding in the crystal structure. So the light waves can bounce off in very rhythmic patterns and create a shimmer. In metals as well, electrons are often more freely able to kind of travel around in metals. They're very simple structures and very consistent, and so that it doesn't create iridescence per se, but it creates that metallic shine in a similar way. But speaking of metals, they often exhibit very different colors when the crystal structure is very large versus almost atomic. So hematite, the iron oxide mineral from earlier, when it's very small, like in our blood, in our cells, it forms a bright red color because the electrons are more tied to what's happening at the surface of the crystal because it's so small. But as it grows bigger, the elements are more, the crystal itself has more of a pull on what those electrons are doing. So they move around more and it becomes like a darker, more typical metal color, more black, usually, at least in the case of iron. But you can see several different metals I've listed. So like gold is yellow in its what we call bulk form, when it's quite large and the electrons are kind of controlled by the metal itself, versus the nano form, which is nanoscopic, just a little bigger than an atom. It's more controlled by what's around the crystal. So gold can be red, it can be purple, it can be blue, just based on its environment. Copper, a big one, like the Statue of Liberty is copper, but when it rusts and you get smaller little copper rust, they can be green. And often they're not as shiny as the bulk color. But in crystallography, we have what's called a streak test. So if you can scratch a metal or any crystal really, you can see what color it would form at the nanoscale, which can be different than the crystal in your hand as you're scratching it. You can see the black scratches and it becomes red. Here's another special case. Fluorite has a really interesting structure. It's basically like a cage of calcium, and inside is a bunch of fluorite, the element. But because there's just, what is there, like 1, 2, 3, 4, like 8 fluorite inside there, it can easily lose a few fluorite and still maintain its structure because the calcium cage, basically. So if anything is causing the crystal to lose atoms, then it can change the color. And radiation from the outside is a big reason for that, but like the tourmaline as well. If anything is changing in the fluid as the crystal forms, or anything, basic things like when you're cooking, temperature, pressure, if you add more or less, it can also change it. So some examples of different fluorite colors. Because its crystal structure can be quite flexible, it can be very, very different. The most common colors, green and purple, usually, well, like a blue-green. The bluish green color is often impurities, so maybe different elements, but the purple is usually the loss of different fluorides inside that calcium cage because of radiation underground. So not like a huge radiation, but just natural radiation caused by the earth, essentially. And then the final case, inclusions or additives. So all the examples I have here are where we have some kind of organic material that kind of fills in the gaps in the crystal structure. So it's not part of the crystal structure, but it's colorful enough that it can create a big enough impact on the look of the crystal. Examples of that are black pearls or amber, which you have whole insects inside amber. And then this bottom crystal here, it's another piece of quartz, and those like yellow blobs is actually petroleum or oil, like you fill up your car with. It found its way inside the crystal as it was growing and then just kind of froze inside as it crystallized. And then another example from our own kitchens is sugar. Sugar is a crystal, and when you put food dye, if you dissolve sugar in water and then put food dye is another organic additive, basically. And so as the sugar recrystallizes around a string or a stick and it pulls that color in with it, it's not part of the crystal structure, but the color is getting bound up into the empty space between the atoms in the crystal. And yeah, we have, I can put it in the chat after I'm done, but I have just a big image of examples for you to look at as you're doing your art. We have the reds, a lot of yellows and greens, basically any color a crystal can be. And like I said, they can be multiple colors. So I will in there. Let me know if you guys have any questions before we start our art section. Are these crystals found in USA or other countries? They're found around the world. Where we are right now in southern Utah, there's not a whole lot of crystals actually, because they're typically found more wherever volcanoes are or used to be. They typically come, well, I guess there's two kinds, like salts. You have salt flats. Those will crystallize at our temperatures and pressures, but like I would say 95% of crystals are coming out of really high temperatures and pressures that form deep underground or from volcanic activity. So, and that happens all around the world. So some places, if it's a rock that basically is like sandstone that's cemented together, the sand is usually quartz, just really fine ground up quartz. So it's technically got crystals in it, but it's not like, you know, sand is tiny. It's not like a nice big crystal. You want to go where like volcanic activity is to find those. Go ahead and like let us get started.
Yeah, you can always ask more questions in the chat and we will be happy to answer. And let's start our art section. So at the beginning, there's someone from India today. So years ago, I painted this. I was learning about Indian deities, and I think it's really interesting. I also put this one over here because, you know, this is the background is made of watercolor and it's going to be the same technique we're going to learn today. So let me repeat the materials we need so that you can go prepare it, okay? We need a watercolor paper, a pencil, and an eraser, a white gel pen or white acrylic marker, and a black ink pen, and a watercolor palette, a napkin, and a jar of water, a brush, okay? I'm using a big brush, but you can use, it depends on the size of the crystal you draw, but we want this kind of fat brushes so that it can hold a lot of water in the brush. If you don't have, you're welcome to watch us. And if you're interested, you can also try at home. It's not a very difficult technique. I think everybody will enjoy it. So we're going to talk about first the shape of the crystals, like Rhiannon was talking about how they were formed. Basically, they're pretty free. You can see in the pictures. Maybe Rhiannon can share the website that she shared with me that had an introduction for all kinds of gemstones and how they're formed. And so you can see the forms are pretty much, they have geometric shapes or they have organic shapes. So today, the painting is pretty free. You can also add some of your imagination. I don't know how many of us are kids, how many of us are adults, but you could always adapt the shapes according to your drawing skills. And drawing is a fun way to explore your inner self. So feel free to make any adjustments if you want. So I have here some shapes that we can draw. So what we're gonna do is we're going to first draw some shapes. It can be geometric shapes, it can be organic shapes, and then we're going to talk about the watercolor technique, and we're going to talk about the colors. So first, on your watercolor paper, I hope everybody's ready with your materials. If you don't have watercolor, you can use color pencil, you can use markers, just have fun. So we are going to draw a group of gemstones. You can arrange them on your paper freely, but talking about composition, I'm not going to depths of composition today, but at least there should be different shapes in different areas. For example, we don't want gemstones like that arranged on our paper. That will make our composition pretty boring. So you can enlarge some of them, or you can put them in a different direction or perspective. So I'm going to just pick 3 different shapes over here on this reference photo. You can draw with me. If your coloring was watercolor, I would suggest that you would draw it lightly with your color pencil so that it doesn't dirty the watercolor later. If it doesn't look exactly the same, it's totally fine as well. If you have some specific shape that you want to draw, you can also let me know. If you have drawing experiences and you can draw 3D shapes, I would be encouraging you to draw 3D shapes. It will make your gems look more 3D, more interesting. But if you cannot, you can also draw 2D shapes. That's totally okay too. For example, you could also just draw a random shape like that. And then you can divide it with different points that you can connect to. There we go. You can also play with the shape. For example, I'm just drawing a random shape and I'm connecting the dots. You can see what kind of shapes you come up with. You can draw some big ones, some small ones. I'm gonna go to the next page so you will have more references that you can use. I drew 5 over here, but you can draw 2 to 3 if you think it's too much, and you can continue explore the shape after the class. Okay, so we're going to continue. If you haven't finished drawing your shapes, you can continue while you listen to basic watercolor techniques. So the basic watercolor techniques, those are very basic ones. We're going to demonstrate on our diamonds a flat wash and a gradient wash and a wet on wet technique. Those are wet on wet technique. This is gradient from a red to black. You can see because it's watercolor, so basically water is doing a lot of the work here. That's another reason I really like watercolor. Sometimes it gives you a really unexpected result. This is the gemstone Rhiannon was talking about over here, the watermelon tourmaline. So you can decide if you want the colors to be a gradient from top to bottom like this or like that. Or you can decide if you want one certain color in the inside, another color on the outside. It can, of course, it can be imagined. It depends on you. It can be a, experiment with different colors as well. You can also do those layers of colors if you like. And let's talk about, look at the colors. You can do from green to yellow to pink to black. You could also do from blue to purple to light blue to orange, something like that. And if you want to have those kind of rainbow rock, if you want to have some like rainbow stripes, you could also add it when it dries up. Okay, so there are really a lot of possibilities, and we can explore each of them. So let's start painting. So first thing I'm gonna do is I'm going to make sure that my brush is clean, and we're going to do a flat wash first. So a flat wash is basically you're going to choose a color. Let's say I'm going to do a flat wash on this diamond. So I will do since it's gonna be Mother's Day tomorrow, probably I'm gonna do a pink gemstone here. And I'm gonna make sure that I have enough paint on my brush, and I'm going to just flat paint it. So this is called a flat wash. If you don't like how it looks while it's wet, you can apply another color. For example, I can apply another purple color. Since I already have, for example, if you want some dots, I'll call it blooms because it's bleeding from the water. Okay, so you can see the magic of watercolor is that it doesn't go outside where you put water. So you do not have to worry that if it's too much water, you cannot control. It does not go outside of your water boundary. Okay, so this is our first practice. We're going to move on to our second practice, which is going to be a gradient wash. What color gradient do you want to do? Can be from top to bottom, or dark inside to light outside, or a dark outside to a light inside. So it really, really depends on you. So with the gradient wash, I'm going to apply a thin layer of water. So what I'm going to do, I'm going to do a gradient from top to bottom. Let's do two colors, which is not going to be very difficult. I will do green and a blue. As you can see, I'm not actively blending it together, like smudging it together, because I already have a layer of water under. Yet the water will do the work and the two colors will blend naturally together. I feel like I want to add some purple on the bottom to make it look more interesting. So if you want to add other colors, you're welcome to do so. Watercolor is actually one of my favorite medium because it's kind of challenging to use it. On one hand, I like the unexpected surprise, but on the other hand, you also have to learn how to control it so it doesn't become a mush of colors. A blended color gradient wash, okay? There are a lot of other ways to do watercolor. Some people spray alcohol to create patterns. Some people apply the food wrap, the plastic wrap to create like texture. Well, hopefully in the future, we will be able to explore more of the watercolor techniques with you. So the third one, we're going to do wet on wet. It's kind of similar to the gradient wash, but can be more free a little bit. So wet on wet is wet brush on wet paper. So first of all, again, you're going to apply a layer of thin water. Let's try a contrast color. What do you think? To see if it will become brown or not. First layer, you can decide if you want a flat wash, like this one, or if you want a gradient color, or if you just want to explore different techniques, how they blend together. Oh, you know what? I'm gonna do a gradient from the middle to the outside. A friendly reminder is that the watercolor usually dries a little lighter than when it's wet. If you want a darker color, you might want to make it a little bit vibrant, like 20% more. It really depends on the quality of the watercolor. So Xinhui is located in South Lake, right?
Yeah, I'm at Salt Lake. I work at University of Utah.
Yeah, so I heard that you guys have a lot of dinosaurs there, like dinosaur bones.
Yes, in our Natural History Museum, and actually at where I'm working, so behind my lab, there's a dinosaur skeleton there. It's really cool.
Wow, that's amazing. So are
Cool.
they actively finding dinosaur skeletons in Utah right now?
Yes. They're not far from where I live. They find quite a lot, although I will be honest, the last, I guess, year and a half, they've been cutting. There's only one privately paid paleontologist. Everyone else is paid by the federal government if you study dinosaurs. And they've been encouraging people to retire, so there's a lot less than there was before, but they still find stuff.
Did we cut this part out in the video when we post it?
Oh, we do have an art question though. They want to know how to use the white marker.
Oh, that is after it dries out, you're going to just trace it and add highlights. Yeah, we're going to talk about it.
I'm curious in the chat if everyone or whoever is waiting for their art to dry, what is your favorite crystal? I think mine is probably opal. I like the iridescent crystals. Oh, we got another opal lover, fluorite. Do you have a favorite color of fluorite?
Yeah, I really like the green one, green purple one.
Mm-hmm.
Oh, I like this color. It's like kind of like a universe. Anna is asking, how do we apply the white highlighter? So it has to be when the watercolor is dry. So another way is wet on dry is my first gem is dry. Then if you want to add a thin layer of texture, you can do it when it dries. So for example, I don't have a small brush, but I'm gonna just do some texture. For example, if you want to do some line textures, or if you want to make some shadows somewhere, you can do that. Now at this point, it won't bleed, so it will be nice. Yeah. You can use white gel pen. I'm using an acrylic marker. And when it dries, you can just trace the edges. And over here, I added some stars and white dots to make it look shiny.
So I have a question about that. I don't have a white marker, but my watercolors came with a white color. Can I also use it in the same way?
Yeah, you can use a small brush and add a very small amount of water, so it can be kind of like toothpaste-like, and then but not too dry, otherwise it will be too thick. And then you can apply it. You can use a small brush to do it. And you can also add some imagination inside. For example, other than just the stars, you can add some, let's say, leaves or some symbols that you like. You can also use the black ink pen. Which result do you guys like? Do you guys prefer more? Because I think Rhiannon and Xinhui had different preferences. The black ink pen or the white gel pen? I see Smita likes the black, right? Yeah, it really depends on personal. Some people like, I mean, even if I don't trace it, I think it looks great. Or if you want to add like a black background or something, that would also look nice.